Today we're going to explore how to use a liquid, water, to measure volume. In previous lessons, you were able to find the volume of a rectangular prism by first finding the area of the base and then multiplying it by the height. Today we are going to use the tools that you learned previously, packing the prism with centimeter cubes and then measuring the area of the base and multiplying it by the height. But we're also going to introduce how to solve for area using water. So for today's task, you are going to need a watertight container. Now I have a food storage container. It's not a perfect rectangular prism, but it's very close. You do not want to use a circle. So any glass air or watertight container you have that is rectangle will do for this task. You'll want it to be on the smaller side because we are going to be measuring volume by putting in our centimeter cubes as well. So I marked a line on my container because I'm going to find out the volume up to this point. Now, the reason why I chose to find the volume up to this point is because oftentimes when we're talking about water, we don't always fill it up to the very top. So the volume is different from the capacity, and we're going to talk a little bit more about that. So for this container, its capacity is up to the line. That's how much this container can hold. But its volume is how much space the whole container or rectangular prism occupies. So you can see it's a little bit different, but we're just going to refer to the capacity as its volume for today's purposes. Okay, my first step with my watertight container is to find the volume by putting in my centimeter cubes. So I'm going to go ahead and do that right now. Okay, so I was able to fill up my container with my centimeter cubes. Now, I mentioned before this isn't a perfect rectangular prism, so things are a little bit off, but I was able to make it about as accurate as I could. Now I'm going to count all of these cubes. There were 190 centimeter cubes in there. Okay, my next step is now going to be to measure it with a ruler. So I'm going to flip it over so I can measure the base first. And remember, I'm going to use my centimeters. So the length is 8 centimeters. And the width is also about 8 centimeters. So length is 8 centimeters. Width is 8 centimeters. So if my length and my width is 8 centimeters, what's the area of my base? The area of my base is 64 centimeters squared. Okay, now I'm going to find where my line is that let me make it a little darker for us. This is where I filled the cubes up to, and I'm going to measure my height. My height is about 3 centimeters. Do you remember how I find the volume if I have my area of my base and my height? Yep, I multiply the two. Go ahead and multiply these and see what you get. 64 times 3 is 192 centimeters cubed. So I was accurate with my counting and my measuring. Okay, so we've done these two ways before. The last way I want to introduce to you to find volume is using a liquid. Now we are going to use water, and we are going to use milliliters to help us measure the volume. 1 milliliter is equal to 1 centimeter cube. The metric system made it that way for it to be easy for us to measure. So this is actually a baby bottle, but I'm going to pretend it's like a beaker. And I have about 192 milliliters of water in it. If all of my measurements are correct, it should go up to about that line. Remember, the reason I'm saying about is because this isn't a perfect rectangle, so there is a little bit more space at the top than there is at the bottom. But we're going to just try our best because this is what we have for today. So here I go. I'm going to pour it in. I know it's super hard to see, but I have just about the right amount of water to get 192 milliliters. So now I have 3 different ways I can measure volume of a container. Let me show you how you're going to document this. I got to get the water out of the way so it doesn't interfere with anything. You are going to need this sheet called Fill It Up. And so we did this together, and I'm going to walk you through how to fill it out. If you do not have the supplies at home, then you just use my example for filling it out. But if you have a container and you have a beaker, maybe you're in a classroom right now, you are going to actually walk through this step on your own. So it says sketch your container. My container kind of looks like this. It was about a square. And then I marked the line right there where I filled my water at. We calculated the measurements by measuring with a ruler, and I just want to remind you of those measurements here. So length was 8 centimeters, width was 8 centimeters, and then height was 3 centimeters. And so our volume when we calculated it was 192. And I'm going to put about in all of this because we weren't super precise. How many cubes? We packed in 193 cubes. And I have to put about again because there was a little bit of gaps. And then finally, how much liquid it can hold? It held about 190 milliliters of liquid. And again, I'm putting about. I want to make sure that we knew we weren't precise. And then what did I notice about these? Well, I noticed that my liquid, my milliliters, was the same to my cubic centimeters, my centimeter cubes. You'll move on to the next page after you explore that on your own. And for each situation, you're going to draw a sketch, then calculate the volume in cubic centimeters and milliliters. So a fish tank is filled to the top with water. The tank measures 15 by 10 by 10. You're going to calculate the volume, first by finding the area of the base, then multiplying by the height, and then you're going to write how many milliliters should be able to fit into it as well. This second one gives you how many cubes, or the volume, that fits into the container. And from there, you need to come up with some possible dimensions of that pencil box. And then finally, there's a prism. You're going to find the volume first, and then you're going to show with the beaker how many milliliters would need to fill up that container. Good luck with introducing liquid to finding volume today.